Welcome students. Today we are going to start a new chapter, radioactivity. So in this chapter we will study about atomic structure, atomic model, and about also nucleus of atom. Okay. And this radioactivity, the phenomena, this phenomena is completely nuclear phenomena. We will discuss. Okay. So first we will discuss structure atom. We have studied also that in atom there is a nucleus which contain positively charged, which is positively charged, and and some electron which are moving around the nucleus. This is the most acceptable model, uh, and according to this model, the electrons move orbiting around nucleus. There is several number of orbits, k, l, m, n, just like that. And in k orbit there is 2 electrons, and in l orbit the electron maximum number of electron may be 8, and there is m now. In case of sodium there is 11 number of proton and 11 number of electron also. That's why in the sodium electronic configuration of sodium is like that: 2, 8 and 1. Okay. The helium has 2 proton and 2 neutron. In case of helium there is 2 proton in nucleus and 2 electron moving out. And in nucleus there is another fundamental particle which is called neutron. Okay. That means the main fundamental particle, these are not properly fundamental, but the the nucleus consists of basically 2 types of particle, one proton and neutron. Okay. Protons are positively charged and neutrons are neutral. It has no charge. Okay, we know electron and negatively charged, which the value of charge is equals to minus 1.6 into 10 to the minus 19 coulomb. Okay. And its mass is 9.1 into 10 to the minus 31 kg. This is the okay, and which is approximately 1 by 1840 times of mass of proton. That means mass of proton is 1840 times of electron. Okay. So the structure of nucleus. In nucleus consists of proton and neutron basic particles, and there is also many more particles like pi mesons, kaons, leptons, positrons. Okay. And nucleus is a very small size of atom, very small. Its radius in order of 10 to the minus 15 meter, which is 1 by 10,000 times of a atom size of atom near above. Okay. So but all the mass and positive charge is compressed within this smaller size. Okay. It consists of proton and the number of proton of the called atomic number. Number of proton in nucleus is called atomic number and denoted by symbol Z. And the proton and neutron which are in main constituent of the nucleus are called nucleons. Okay. What is nucleons? Nucleons is the proton plus neutron. The total number of nucleon in nucleus is called mass number, and mass number is denoted by A. So atomic number means number of protons, okay, in the nucleus of an atom. The number of proton or electron. We all know the atom is neutral. That's why the number of proton is equals to number of electron. And mass number is the total number of proton and total number of nucleon. And the atom is specified by symbol X, A, Z. A is the mass number, Z is the proton number or atomic number. Okay. X is the chemical symbol of element. X may be hydrogen, H. For hydrogen, X will be H, and for helium, X will be He. Just like for iron, H will be Fe, X will be Fe, like that. The mass of an atom is small, so small that it inconvenient to express in kilogram. Okay. Because the mass of proton in kilogram is near about 1.67 into 10 to the minus 27 kg. So it is not convenient, inconvenient. So we use different unit of mass. This is called atomic mass unit or AMU. Okay. AMU. AMU is the definition of AMU is that the 1 mu defined as 1 by 112 times the mass of carbon isotopes C12 6 isotopes. Okay. This is the called AMU, and we know Avogadro number is 6.023 into 10 to the 23. Mass of 6.023 into 10 to the 23 atom is 12 gram. So 1 AMU means now 1 by 12 into mass of C12. So mass of one atom of C12 is 12 by gram, and AKMU is the 1 by 12 into atom, near about 1.66 into 10 to the minus 27 kg. 1 m. So this is called atomic mass unit. And atomic mass can be measured by a device which is called mass spectrometer. Okay. So the composition of nucleus is described using following term. The composition I have told already. Z is atomic number or number of proton, N is the neutron number, number of neutron, and A is the mass number equals to Z plus N, and nucleus is specified by XAZ. Okay. So the parameter are charge and mass. Charge is described by electronic charge is 1 minus 1.7 minus 19, and proton has same charge but positive, and neutron has no charge, and the symbol is electron symbol is E, proton symbol is P, and neutron symbol is N, and mass is proton electron mass is 9.1 into 10 minus 31 kg, and proton mass is near 1.6726 into 10 minus 27, and neutron mass is 1.67 near about 6782 into 10 to the minus 27. Okay. Mass of proton and neutron nearly same but slightly greater. Neutron mass is slightly greater than proton. So we have seen that in nucleus there is two types of basic two type of particles. One is proton and neutron. So but and the number of proton is equals to number of electron. That means number of proton define the most of the property of nucleus. Like the electronic configuration only depends on the number of protons, and but there is, if we change the proton number, then atoms will change. So that sodium has proton number 11. Okay. But for helium proton number is 2. Means the proton number define the name or property of nucleus. If proton number change, that means material change. So but there is some element which have same proton number but different neutron number. That means different mass number but same material because same proton number. These are called isotopes. So definition of isotope is very important. So the atom belonging the same element with same atomic number. So as atomic number same, that's why it's belonging to same element, but different in their mass number are called isotope. Due to difference of differing neutron number, the mass number is different. The atom isotope have same number of proton but different number of A minus Z means neutron. We know the A is Z plus N. Okay. Two kind of isotope, some elements. One is stable isotope which have number of neutron is nearly equal to number of proton. They are nuclei. And unstable or radioactive isotope which undergo radioactive decay and are of great medical and industrial use. They have more neutron than proton in nuclei. The example are the hydrogen H11 is the ordinary hydrogen, deuterium is H21, means in hydrogen nucleus we know only one proton, but in case of deuterium there is one proton and one neutron in nucleus. In tritium there is one proton and two neutron. Okay. In case of carbon we know carbon is the Ca612, but it has another isotope C614. Okay. This is called radioactive carbon or radiocarbon. And another term is isobar. Isobar means the atoms of different element, because Z number is different here. Same mass number but different atomic number or Z are called isobar. So isobar has different Z number, must be. Okay. And as Z number difference, so these are different element, but isotopes are the same element. Example, sodium 1123, magnesium 1223. They have same mass number but different proton number. Isoton have same neutron number. It has also different number of proton but same number of neutron. Example, sodium and magnesium, these are also isotons because they have same number. They have same number of neutron. So till today we have discovered near about 118 type of atom. Means 118 type of materials, but they are all are not stable. Some are stable, some are unstable. The atoms having Z less than near about 82, they are nearly stable. Okay. Maybe they have some isotopes, they are unstable also, but nearly Z less than 82, they are stable. But when Z greater than 82, the atoms having Z greater than 82, they have we know that in nucleus there is large number of proton is compressed, so they have repulsion force. Okay. The repulsion force dominate the nuclear attraction force. Okay. That's why they are not stable. Okay. So they, to get stability, they radiates some or they emits some particles. This emission is called radioactivity. So some heavy nuclei having Z greater than 82 radiates some particle to get stability. Okay. So this type of radiation is called radioactivity. Okay. And also some isotope having Z less than 82. Let us say example of C14. C14 is a radioactive isotope of carbon, C14-6. Okay. It emits radioactive some radiations to get stability. So this is the radioactivity. So Henry Becquerel first discovered the phenomena of radioactivity in 1896. Okay. Once in a dark room, he left uranium salt wrapped in black paper on a photography plate. After some day, he was surprised to find that photography plate had been affected. Okay. And later on, the same observation was made with other salt of uranium. From this observation, he concluded that uranium and its salt by themselves emit some kind of radiation which can pass through the cover, a black paper, gold, a glass or wood etc. of the photographic plate and affect it. These radiation were called Becquerel radiation. Becquerel ray. On further investigation was done by Rutherford, and he told that the radiations, there is three type of radiations. One is positively charged, and one is negatively charged, and another is uncharged radiation. Okay. The positively charged radiation is known as alpha, and negatively charged radiation is known as beta, and gamma is the radiation which is neutral. This is not particle, this is only electromagnetic wave. I have told that the isotope nearly all element atomic number higher than 82. Okay. After lead on the periodic table are radioactive because their nucleus, the number of neutron is much more than number of proton. Okay. These are called nuclear radioactive substance. So radioactivity is a nuclear phenomena. It It is independent on the pressure, temperature, or environmental change. Okay. This is important question. So that radioactivity is a nuclear phenomenon. Any physical change such as change in pressure, temperature, or chemical change such as excessive heating, freezing, action of strong electric and magnetic field, chemical treatment, oxidation, etc. does not change the nature of radiation emitted by the substance and rate of decay. Okay. This clearly shows that the phenomena of radioactive cannot be due to the orbital electron, which could easily be affected by such changes. Okay. We know the chemical reaction is the due to orbital electrons, which can be changed by some external effect. But radioactive phenomena does not depend on the external changes. And radioactive decay is the random phenomena. Okay. This is random phenomena. From radioactive substance contain very large number of atoms. There is no way to know where, when or which nucleus of the atom will decay at any moment. Hence radioactive decay is the random phenomenon. So radioactive material emits three types of radiation. One is alpha particle emits. The alpha decay is called the emission of alpha particle. Beta decay the emission of beta particle, and gamma decay is the emission of gamma radiation. Okay. So this is the definition. What is radioactive substance? And I have told that Becquerel radiations given out by radioactive element. Property: they are gas ionizers. They ionize the gas. They affect the photographic plate. They can penetrate through matter. They are affected by electric and magnetic field. Okay. The radioactive substance affected by the radioactive particles which are emitted from radioactive material are affected by electric and magnetic field, but radioactivity does not affected by electric or magnetic field. Okay. So experimental demonstration on property of Becquerel. The experiment was done by Rutherford. Okay. So the experiment setup is taken in vacuum tube or vacuum chamber, and one lead cube is taken and a radioactive material is placed within the lead cube, and this radioactive material he has taken uranium. Okay. So uranium emits some particles and electric field is applied here. That means the positive plate attract negatively charged and negative plate attract positively charged. Then and photographic plate is kept here, so that, and the experimentally, this is the experimental setup, and he got the result that A is the very dark spot. A, this is the A point, this is B point, this is the C point, and C is medium spot, and B is the very light spot. Okay. And also Rutherford applied magnetic field, perpendicular magnetic field, and he observed that same observation that the some particles are deflected by magnetic field and some particles are not deflected. So those which turn left must be positively charged and are called alpha particle, and those which turn right must be negatively charged, these are called beta particle. Those which was deviated must be uncharged or neutral, as called gamma radiations. Gamma radiation is the electromagnetic wave similar to the light wave. Okay, but it has high frequency, very high frequency, and it has very high penetrating power. So we will discuss some property of alpha, beta, and gamma radiation in the next class. Okay, that's all for today's class. Bye.